This will be the first video for section 4.2 assignments. We'll probably get through about 1 through 3 or 4 on this first video. So question 1 says, use analytic methods to find the local extrema, the intervals in which the function is increasing, and the intervals in which the function is decreasing. All of those answers can be found by simply analyzing the derivative. First question is a quadratic, so the domain is all real numbers. So we don't really need to worry ourselves about that. So let's take the first derivative, which is 5 minus 2x. To find where the function is increasing and then decreasing, we want to pinpoint where the function's derivative is 0, because then, because the border between positive and negative is 0. So we're going to set our derivative equal to 0. And I get x equals 5/2. And that's my only critical value. So what that means is that's the only place where my slope is 0 or undefined. And so now I just want to look at a sign chart. And I'll put 5/2 on my sign chart. And I need to pick a number greater than 5/2, like a billion, plug that into my derivative, and I get a negative number. Plug in a number like 0 or anything less than 5/2, and I get a slope that is positive. So I have all my answers. A, B, and C. B is where is it increasing, and that's where the slope is positive. So from negative infinity up to 5/2. We'll say not including 5/2, because at 5/2 the slope is 0, which means it's neither increasing or decreasing. C is going to be decreasing 5/2 to infinity. And A is going to be identify the local extrema. Since we go from positive to negative, we know that the point 5/2 is a local maximum at x equals 5/2. And the max is, find the local extrema. You know what, I'm going to let you find that to save time. So f of 5/2 is my maximum. And that's it. So question 2, same thing. We're going to use our first derivative to analyze this. 2x minus 1. So we're going to set it equal to 0. And I get x equals, add 1 divided by 2, I get a half. I have 1 critical value. There are no places where the derivative is undefined. And so once again, in my derivative, I'm just going to plug numbers on each side of a half. So I'll plug in 1,000,000, and that's going to be a positive number. Plug in negative 1,000,000, and that'll be a negative number. So this time, I have a part A, a local min, and that'll be at the point 1/2, comma, and I'll let you find the y value. Plug it back into g of x. Part B is when is it increasing, so this will be 1/2 to infinity. And C, when is it decreasing, negative infinity to a half. Please understand you have to read this in context. A minimum is a single point. So the parentheses indicate a point. These are open intervals. These are basically domains. Where, and I'm saying from 1/2 to infinity. All right, question 3 is asking the same thing. And so I will first take a look at domain in this case. I know that for this problem, x cannot equal 0. So 0 is not part of my function. It won't be a local max or a local min. There is no value. All right, so let's take our derivative. And I'm going to do this not as a quotient, but I'm going to do it as a negative exponent. So I'm going to kind of think about this problem as being 2x to the negative 1. So then my derivative is going to be negative 2x to the negative 2. Or negative 2 over x squared. So there's my derivative. So now I want to find out my critical values. So I'm going to set my derivative equal to 0, and there's no way that that's going to happen because the numerator can never equal 0. But in this case, I'm also going to consider when is the derivative undefined, and that'll be when x equals 0. So x equals 0 we know won't be a max or a min because it's not even part of the domain. However, and hopefully we know it is an asymptote, so we're still going to do our sign chart and plug the 0 in there, because let's just take a little look over here. If you have an asymptote, let's say right here, we could still change from increasing to decreasing. So let's just say this won't be the graph of this function. So over here my slopes are positive, and here my slopes are negative. So even though I didn't have a local max or a minimum, I still changed from increasing slopes to decreasing slopes. Another asymptote could have looked like this instead, and that would have been a positive slope to a positive slope. So you can still have slope changes at vertical asymptotes, so it's important for us to still put the 0 critical value on our sign chart, even though we know it's not a minimum or a maximum. So I plug in a number greater than 0 into my derivative, and since I'm squaring, I'm always going to get the same value. So I'm going to get a negative divided by a positive as a negative, and I'm going to get a negative. So no matter what I plug in, the slope is going to be negative. So, ready to answer the questions. A, where are my local mins and maxes? I don't have any. Part B, where am I increasing? Never. And part C, where am I decreasing? And so the answer to that question is going to be from negative infinity up to 0 and 0 to infinity. I use the word and there sort of arbitrarily. What I really mean to use is the word or. It's got to be here or here. Okay, so now we're done with this question. Just to verify that we've kind of got it right, we should think about the graph of 2 over x. We know the graph of 1 over x looks like this, with a vertical asymptote at 0 and a horizontal asymptote at y equals 0. And this matches what we found. No value at 0. We are constantly decreasing on this side, and then when we pick things up here, we are constantly decreasing. And so our answer works. Okay, so now let's do number 4, the derivative of k. Again, I'm going to do this as a negative exponent, so I'm going to look at this as x to the negative 2. So the derivative will be negative 2 x to the negative 3, or negative 2 over x cubed. So when is the derivative equal to 0? None. When is the derivative undefined? And that would be at x equals 0, which reminds me we did not consider our domain, but again it should be pretty obvious at this point. 1 over x squared, we can't use 0. So 0 is going to be a vertical asymptote. And since it's not continuous at 0, the function, it's obvious that therefore the derivative would also be undefined at 0. And let's do a sign chart real quick. And our only critical value to add is 0. And now let's plug in numbers and see what our slopes are. So we'll plug in a number greater than 0, and I get a negative over a positive. I plug in a number less than 0, so negative number cubed is negative. Negative divided by negative is positive. So I'm ready for my answer. A, B, C, increasing from negative infinity to 0. That's where the slopes are positive, and decreasing from 0 to infinity. There are going to be no local max or mins because we have an asymptote at 0, and the graph of 1 over x squared looks like this. So we have no local max or mins. At 10 minutes, I'll stop this video. We'll pick it up with number 5 on the next one.